Hello, everyone. Like just Martin said, I'm going to give you a little overview of Jellyfish, which is a multimedia server that we've been working on at Software Mansion for the past few months, which is built in Elixir, powered by Membrane and Phoenix, like the slide said. And before that, my name is Łukasz Wala. While I work here at Krakow at Software Mansion, mostly on multimedia and WebRTC stuff. You can find me on GitHub and on Twitter. So, what is this talk going to be about? I'm going to give you a little introduction to the concept of media server and protocols involved in networking and multimedia stuff, because I know some of you might be not familiar with this stuff. Then we're going to do a basic overview. I'm going to tell you about the basic concept of Jellyfish. Then we're going to do a brief look under the hood of Jellyfish. There's going to be a little demo at the end. What is a media server? So basically, as we understand it, media server is simply a piece of software that you run on your backend that takes some incoming media, obviously. Sometimes does something with it, but not necessarily, and then sends it somewhere else. As simple as it gets. If you've ever worked with WebRTC, you might have heard the abbreviation SFU, which stands for Selective Forwarding Unit. And the name is quite self-explanatory. It selectively forwards some media traffic. And this is exactly what Jellyfish is. And you might be asking, well, similar solutions already exist in the market, so why are you building this thing? And before I answer this question, let me give you a little introduction to some of the most common protocols and standards used in media networking. And the first one is WebRTC, which is a standard developed in the last decade, and it's basically used in all of the big video conferencing solutions like Google Meet, Microsoft Teams, WebEx, Zoom, etc. It was designed as a peer-to-peer standard to peer-to-peer communication, but nowadays it's also used with some servers and central units that forwards the media, like the SFU I mentioned before. And it's based on RTP. It has a very low latency. And usually, when you use WebRTC, there's communication, and there's two-way communication. So you receive and send media. For instance, in a video conferencing solution, the participant in the meeting could send and receive media. And on the other side of the spectrum, there's HLS, which is a broadcasting protocol. So it is used, for instance, in video-on-demand solutions and live streaming. For instance, Twitch uses HLS. It is based on HTTP. It basically works as follows. You have your video in format that is similar to something like MP4, then it is sliced into segments and simply served with HTTP. Because of that, the latency is quite a bit bigger than in case of WebRTC, and like I said, it's used mostly in live streaming and video on demand. And the last protocol that I want to mention is the RTSP, which is, I think, not as interesting as the other two, but nowadays it's mostly used by IP cameras to basically send a stream. If you ever looked at an IP camera feed in your browser, for instance, from some city, there's one on the Krakow Old Town. It's probably uses RTSP. And I'm talking about these three because these are exactly the protocols that Jellyfish supports. So when usually solutions on the market, other media servers focus on one thing, like the WebRTC. We wanted to create a very extensible solution that can bridge different types of standards and protocols. I'm going to show how we can achieve it in just a moment. But for instance, with Jellyfish, you could create a video conferencing solution when you also compose all the streams into one and then serve it via the HLS. So, but before the examples, I need to explain the basic concepts of Jellyfish. And these are rooms, peers, and components. And rooms, which is quite telling, these are basic containers for other types of elements. So when you are talking about a video conferencing solution, room would usually mean something like a meeting. Then you can use the rooms to group peers and components. And peers and components, there's a crucial difference between these two tabs, and I'm going to mention it in a moment. But now let's see an example. The only type of peer that we currently support is the WebRTC peer. Going back to the web video conferencing solution, WebRTC peer would represent like a participant in the meeting. So the usual flow of using WebRTC peer with Jellyfish would be something like this. You have your video conferencing app, and there's the client, your app's front end, and your app's backend. Client joins, so participant wants to join the meeting. He will send some kind of request to your backend, and then backend can take care of calling the Jellyfish API to add the WebRTC peer. Jellyfish will usually respond with confirmation with the peer token that you can see on the third arrow on the slide. Then your app's backend can have to somehow pass the token to the client, and client can open a signaling channel, which is under the number 5 on the slide. The signaling is necessary for WebRTC to establish the connection because there needs to be exchange of some metadata that is necessary to then start sending the media. And like I said, the WebRTC peer would usually mean, for instance, maybe a participant in a meeting in your video conferencing solution. On the other hand, we have the components. And there's two types of components at the moment. There's the RTSP component, which you can use to receive the RTSP stream. So let's say there's some IP camera that uses RTSP to transmit its feed. You can add the RTSP component to Jellyfish using its API. And then you simply have access to the feed from the camera, and it can be then forwarded to other types of peers and components. There's the second type, which is HLS component, and it's exactly opposite of RTSP. RTSP only produces media and streams. On the other hand, HLS consumes all of the media, all of the streams from other WebRTC components and RTSP components, and composes them into one single stream. And how the composition works, I'll talk about that in a minute. And then Jellyfish takes care of serving the HLS stream via HTTP. All right, so here's the most basic example that shows how you can combine different types of peers and components. Here we have the usual video conferencing solution. You have your participants, you have your meeting. You add each of the participants as a WebRTC peer. So then each of the WebRTC peer can see every one of the other peers, as usual in the traditional video conferencing solution. But then you can add the HLS component, which will take all the streams from WebRTC peers, compose them into one single stream, mix the audio, and serve it via HTTP. All right. Here's a second example, which is RTSP to HLS. It's very similar, but instead of using the WebRTC peers, we use the RTSP components. So let's say you have a network of surveillance cameras, and you want to show the feed from the cameras in your browser, or maybe access it on your phone. You can create a Jellyfish instance with a single room and add all of the cameras as RTSP components to Jellyfish. Next, you can add the HLS component, which will, just like before, mix all of the audio and compose all of the video into one stream and serve it via HTTP. All right, so this was the basic examples of how Jellyfish can be used. But now let's take a brief look under the hood and how does it work. Like I said, Membrane is based on Jellyfish is based on Membrane, which is the framework we have built at Software Mention that you can use to create multimedia pipelines. So basically, this is a screenshot from a tool that we use to visualize these pipelines. The blue rectangles are the membrane elements, which basically are, simplifying a bit, basically these are processes or threads that consume some kind of data. It doesn't have to be media, but obviously in this case it is, and then produce some kind of data. All of the blue rectangles on the screenshot are the T components, which simply multiplex the data. So they take one input and produce multiple inputs with exactly the same stuff as in the input. The green rectangles are membrane bins, which are basically containers for other elements. I'm going to show you how you can expand this green rectangle to see what's inside on the next slide. But basically, this is a screenshot from a single room in Jellyfish, and there's all the different types of peers and components that I mentioned before. And this is the RTSP component. So, like I said, it only produces. So it takes a stream from some kind of IP camera, let's say, and then the stream is forwarded to all of the other types of components. In this case, these are the WebRTC peers and HLS component. This is the HLS component, which consumes the stream from all of the other types of elements. So it takes the stream from WebRTC peers and RTSP components and creates a single HLS stream, which is then served via HTTP by the API layer of Jellyfish. And the last one, this is the WebRTC peer, which can consume data from other types of peers and components and also produce media. For instance, your participant in your video conferencing meeting will usually produce some kind of audio, for instance, from his microphone and maybe a camera feed or some screen sharing. And all of this is forwarded to other WebRTC peers in Jellyfish Room and the HLS component. This is how the HLS pipelines look. This is the expanded green rectangle from the previous example. In this case, it's very simple because it takes only one video and one audio stream, so the composing and mixing part doesn't really do anything in this case. And as you can see, it really is a pipeline. So there's different elements, and they do different stuff, which I can show you here. And this is basically how it works with other types of peers and components. So WebRTC and RTSP uses RTP, which is a protocol based on UDP. But to use it in HLS, we have to somehow take the payload out of the RTP packets. We can use the RTP depayloader membrane elements. All of the rectangles on this example are basically membrane elements. After the media is depayloaded, so we can get to decoding. In case of WebRTC and RTSP, we have different types of encoding that we can use. In case of video, it might be VP8 in WebRTC, or maybe H.264 in case of RTSP. These are simply different types of video codecs. And in this example, I used AAC, which is an audio codec for both WebRTC and RTSP. Then all of the media from video, all of the video goes into the video compositor, which is an element that mixes, or rather composes, all of the videos onto one single frame. And I'm going to show you in practice in the demo at the end. And all of the audio goes to the audio mixer, which simply mixes all of the audio streams. Then the video and audio is once again encoded, and the CMAF, which is a type of container used by HLS, which is basically the sliced up segmented MP4, takes care of payloading it, and then the API layer of Jellyfish serves it via HTTP. So that was the multimedia part of things, but I guess the API is as important. We use REST, a simple HTTP REST to enable adding and removing the different types of elements, so rooms, peers, and components. And usually your app's backend would take all of this. And also we allow to receive some kind of notifications from the Jellyfish. So for instance, Jellyfish can produce notifications about room crashing, or maybe that the peer has just connected. And you can use the WebSocket API to simply receive the notifications. There's also the API for the client, which in this case is mostly used by WebRTC for the signaling channel and the metadata exchange. You can see it on the number 5. And obviously doing all the requests and HTTP and WebSocket stuff by hand would be quite tedious, so we've created some SDKs. In case of the backend, so the SDK for creating rooms, receiving notifications, we have SDKs in Elixir and Python for that. And there's also the client SDKs in TypeScript, React for mobile stuff, iOS, Android, and React Native, I believe. All right, so before I get to the demo, I also need to mention the dashboard, which is a tool that we've built to make it easier to develop the application. It basically can do everything that the SDKs can do, but it's nice web app format, so it's easy to debug when developing stuff on Jellyfish. And the last thing I want to mention is the load balancing. We wanted to make Jellyfish very easily horizontally scalable. So the basic load balancing is the first step in this direction. You can create clusters of Jellyfish instances, and then when you want to create a room on a single instance, this instance will ask all the other instances for some feedback with resource usage, and then decide which instance is the most suitable to create the actual room. It's usually the least used one. All right, so I have this little demo. Maybe let's start with that. For internal meetings and membrane teams who use this app that we developed. It's obviously based on Jellyfish. Let me run it real quick. I have to host it locally for this example. So this is the app that we use for our internal meetings. And basically, simple video conferencing app. And I want to show you an example of manually adding the HLS endpoint. So we can stream the meeting by using the HLS. So here I have the meeting. You can see it works just fine. I'm sorry, I have to... Let me just join to the same room maybe. Okay, so I'm joining from the demo. I do the same thing here. Right, so this is a simple video conferencing app. But now we can use the API, which I have here on the presentation, to manually add the HLS endpoint to the instance of Jellyfish. So what we're going to do is to install the Jellyfish Server SDK, which is necessary to do all of the requests. Then we're going to create a client struct, which is basically a struct aggregating all of the information necessary to create the requests. We know that there's only one room on this Jellyfish instance, so we can use the getAll call to somehow obtain the ID of the room, and then we use the add component function to add the HLS component. So I'm going to do exactly that here. As you can see, this is exactly the script that I was talking about. And I'm going to call it with Elixir. As you can see, there's this URL printed. Let me copy it real quick. And we can use some demo HLS player for, in this case, this is the HLS.js example to play the stream. As you can see, this is exactly all of the composed streams from the meeting. So in this case, it's just me. But usually when you have maybe multiple tracks, it will dynamically compose all of the videos onto a grid. And that was basically it. So this is Jellyfish. I hope you now get the basic components and know how to create basic solutions and multimedia apps with Jellyfish. Thank you.
Thank you, Łukasz. Are there any questions? There is another mic somewhere there on the back, if anyone wants to ask any questions. Yeah, okay, so.
Where's the name Jellyfish from?
Maybe you've seen the membrane logo. So Jellyfish was supposed to be initial name of the project that we're supposed to rebrand it further on, but it's basically stuck on, so it's probably going to be Jellyfish forever now.
Yeah, okay. Jan?
Hey, great talk, thanks. Very impressive software. I have one question about the horizontal scaling thing. So once the rooms are made, they're pinned to the instance and they don't move, even if they're like modified. If you will add more components, it will not reevaluate the resource usage and then move it maybe? This one works?
No. Yeah. 1, 2, 1, 2. So at the moment, this is the only thing that we support. We're working on doing rooms that can span multiple Jellyfish instances, but that's still in progress. So basically now it's only the ask other instances for the resource usage, and then choose the least used one and create the room there. But we've planned to do some more features regarding the scaling.
Thank you.
I just wanted to follow up on that. So how do you do discovery for all the Jellyfish servers? And are they connected in a full-blown mesh where each Jellyfish server is connected to every other?
Yes, because this is all built in Elixir. We use the Erlang distribution. You have to create the clusters manually, so you have to, when creating Jellyfish instances, you have to pass the addresses of all the other instances, and this is basically the full mesh. So the instance that is receiving the call to create a room will basically ask all the other instances for the resource usage at the moment.
Thank you.
Okay, so I saw on the diagram that you use protobuf for signaling, and there's an option to use a different type of data, as it's really tricky to use it on the front-end side.
At the moment, no, but we plan to also add the support for webhooks to make it easier to use with some cloud services. So now basically you have to use the protobus.
Anyone else with the questions?
Any other questions? All right, thank you for listening.